We can look at two examples of how we can use the derivation rules that we've just learned, the rules for reiteration, introduction of conjunction, introduction of implication or elimination of conjunction or elimination of implication, to construct derivation for relatively simple claims, namely that phi implies phi and phi, or that phi, this is known as idempotency. So if you have a certain phi, then this implies phi and phi. This is a rather trivial claim, as you can see. Or commutativity, namely that phi implies psi, phi and psi implies psi and phi. So this is an inversion of the conjuncts, where one comes first, then it comes second, and what comes second comes first. So this is the property of commutativity. Now, we can see that we can construct derivations that establish these rather trivial claims, and in doing that we can see how the rules of derivation can be used and applied. Well, let's start with the simplest claim, that phi implies phi and phi. What we should do here, we start with assuming phi twice. So the square brackets that you see around the formula phi mean that we are assuming that formula. So we are assuming that formula and we are labeling it with the number 1. Now, we can use the rule for conjunction introduction to write phi and phi. So this is a straightforward application of the rules for conjunction introduction. And then we can apply the rule for implication elimination. And in doing that, we discharge our assumption phi, and we can write the implication phi implies phi and phi. Now, one thing to note here is that the same assumption phi has been used twice. You can see that it's repeated 2 times on top of the derivation tree, but then when we introduce the rule for implication introduction, we cancel it all at once. So the rule cancels both instances of phi, although we have used the rule only once. So insofar as both instances of phi are on top of the tree that we used to derive this conclusion here, they can both be cancelled. Let's now consider the commutativity claim, namely that phi and psi implies the inverse, namely psi and phi. We start our derivation tree by assuming twice the conjunction phi and psi. So this is repeated twice on top at the beginning of our derivation. Then by the same application of the rule for conjunction elimination, we can write in one case phi and in the other case psi. So we apply the same rule for conjunction elimination, but in one case we pick out the second conjunct and in the other case we pick out the first conjunct. Then we can use the rule for conjunction introduction. So we have phi and psi, and so we can combine the two together with phi and psi and phi. And then finally we use the implication elimination rule, and we can cancel our two assumptions of top of the tree. It's the same assumption repeated twice, and we have finally derived what we wanted, namely that phi and psi implies psi and phi. This is the commutativity property that we wanted to derive.